Today I want to talk about the variables which we use in scientific research and scientific experiments. Exactly what is variable and what are its type? Let's start. All the physical quantities which we are using in the study of the science are variables, and they are distance, displacement, velocity, speed, acceleration, force, solubility, rate of chemical reaction, current, potential difference, work, energy, power, etc. There are many physical quantities which we have studied in the study of science, and all these are actually variables in the scientific study. So, I want to start with the physical quantity first. Exactly what is it, and then we'll enter into variable. What is physical quantity? Quantities which can be measured directly or indirectly is called physical quantity. I think you know about this. If we have to measure the length of a room, then we can use an inch tape and we can measure the length of the room. But for area of the floor, we have to measure breadth also, and then we have to use a formula, area equal to length into breadth, and multiplying length and breadth, then we'll get area. This way, area cannot be measured directly. It is indirectly measured by the multiplication of length and breadth. So, some of the physical quantities can be measured directly, some cannot be measured directly, it can be measured indirectly. The quantity which can be measured is called physical quantity. Now let's talk about the variable. What is variable exactly? In the study of science, a variable is any factor, trait, or condition that can exist in differing amounts or types. In the study of science, a variable is any factor. What it means? Factor means factor may be distance, displacement, velocity, speed, acceleration, force, etc. All these variables are factors. And variable may be the trait, characteristic, solubility, rate of chemical reaction, etc. Or variable may be the condition also. The conditions like sunlight and water, heat and cold, use of catalyst or not used, etc. That's why in the study of science, a variable is any factor. It may be trait or condition or it may be a factor. And it exists in differing amounts or types. What it means? Differing amounts and types. It means it can take different value under certain limitation. Just for example, distance can take any value. In the same way, so solubility can take certain value within certain limit. And they take different value. That's why they exist in differing amounts or types. According to their dependence, we can divide into different types. Just for example, some variables are not dependent on others, but some are dependent on other. Some variables cannot be manipulated, etc., etc. Accordingly, we can divide them into different types. Okay, that's why in the study of science, actually a variable is any factor, trait, or condition that can exist in differing amounts or types. Now I want to establish the relation between the variables in the scientific study and experiment. In many scientific study, in almost all the scientific experiments and scientific research, the relationship between the variables are established. And this is very important, how a variable is related to other. Why don't we take very simple example for this? I think all of you know Newton's second law of motion. When we proved F equal to ma, we have done this. The relation between acceleration and force was established at that time. Now let's talk about the experiment of that time. Let's say this is a 1 kg mass and 1 Newton force is if applied on it, a constant force, then certainly acceleration produces on it. And it accelerates with the acceleration of 1 meter per second square. What is the meaning of acceleration 1 meter per second square? If its velocity increases by 1 meter per second in every second, then its acceleration will be 1 meter per second square. Okay, now I want to repeat the experiment, but at this time, if we apply 2 Newton force, then what happens? Its acceleration increases. That's why I'm showing a little fast motion. And acceleration is found to be 2 meter per second square. What it mean? Every second, if its velocity increases by 2 meter per second, then the acceleration on the body will be 2 meter per second square. If we apply 3 Newton force on the same 1 kg mass, then what is found? Its acceleration is found to be increased. I am showing the motion faster to show that its acceleration is more, and its acceleration is found to be 3 meter per second square. And what we did at this time, we are establishing the relationship between acceleration and force. And what is found? When force increases, then acceleration also increases. And we can say that acceleration is directly proportional to the force, and symbiotically A is directly proportional to force. But at this time, I want to relate it with variable. Here we have distinctly two variables. One is force, another is acceleration. When force is increased, we are manipulating the value of force. Once it was 1 Newton, again we applied 2 Newton, again we applied 3 Newton. We are manipulating the value or changing the value of force. This variable to which we are giving different value is independent variable. That's why in this experiment, force is independent variable which can take different value. The effect of increase of force is seen on the acceleration. The value of acceleration depends on the value of force. So acceleration is dependent variable. Force is independent variable. We are manipulating its value, and its effect is seen in acceleration. Acceleration is dependent variable. So we can conclude that force is independent variable and acceleration is dependent variable. I want to bring back to the same diagram. Look at this. When 1 Newton force is applied, then 1 meter per second square acceleration is found. If 2 meter force is applied, and if someone says that acceleration will be 2 meter per second square, then I can say this is wrong. And if he asks me question why wrong, then I can say that if this mass is increased to 4 kilogram instead of 1 kilogram, then certainly its acceleration will be less than 1 meter per second square. Increasing the force all the time, acceleration cannot be increased. We have to see the mass also. Now there is third variable also, we have to see it. What it is? It is the mass of the body. And mass of the body is taken constant throughout this experiment. It means this is called control variable. When we increase the force on the same 1 kg mass, then only acceleration will increase. But if we increase the mass also, then this experiment will fail. That's why when relation between two variables are being established, then third should be in control. That is called control variable. So I can say that force is independent variable, acceleration is dependent variable, but mass is control variable. Okay, let's go to the same Newton's second law of motion. What we did at that time, relation between acceleration and mass also established. When 1 Newton force is applied on 1 kilogram mass, then the acceleration produced will be 1 meter per second square. If we increase the mass, if it is made 2 kg and same amount of force 1 Newton is applied, then acceleration will be less. I am showing it by the slow motion of this 2 kilogram mass. Acceleration will be just 0.5 meter per second square. It is decreased. If 4 kilogram mass is taken and the same 1 Newton force is applied, then acceleration will be less than the previous. I am showing it by very slow motion of this 4 kilogram mass. Its acceleration will be 0.25 meter per second square. What is the conclusion of this experiment? When mass of the body is more, acceleration will be less. It means they are inversely proportional to each other. That's why we can say that acceleration is inversely proportional to mass. But we are not talking about the force. Force is taken constant. It is not increased. When we are establishing the relationship between the mass and acceleration, at that time force is taken as constant. In this case, the value of mass we are manipulating and its effect is seen on the acceleration. That's why mass is independent variable, acceleration is dependent variable, and throughout the experiment force applied on the body is constant. So this is control variable. Okay, we can declare this in symbiotical form also. Acceleration is inversely proportional to mass. In scientific research and in other research also, the variables can be represented by symbol. Okay, mass is independent variable, acceleration is dependent variable, and force is controlled variable at this time. Now I want to show another experiment also which you know, Ohm's law. How we proved this? Look at a cell is if connected to a resistor, then current flows from positive to negative terminal according to the concept of conventional current. If you want to measure current flowing through this resistor, you can use ammeter. It should be connected in series for the measurement of current. And if you want to measure potential difference across the resistor, you can use voltmeter. This way a circuit is made in which cell is connected to resistor and current and potential difference across the resistor is measured. The same experiment can be repeated by using 2 cells and 3 cells also. Exactly what we are doing in this experiment, instead of 1, if 2 cells are used, then per coulomb charge more electrical energy is supplied in the circuit. And if 3 cells are used, then more than that is again supplied in the circuit. And due to this reason, the potential difference across this resistor is found to be increasing. Our target is to increase potential difference and its effect is seen in current. When potential difference is increased, then current is also found to be increased. In second case, it is more than first, and in third case, current is found more than second also. This way, what can we conclude? Potential difference is directly proportional to current. This is Ohm's law. The heart of the Ohm's law is potential difference is directly proportional to the current. At this time we are not writing Ohm's law properly because we are not related with that. Actually Ohm's law can be written this way: when physical conditions and temperature remains constant, the current flowing through a conductor is directly proportional to the potential difference between its 2 ends. But the heart of the Ohm's law is potential difference is directly proportional to current. Symbiotically V is directly proportional to I. Now I want to come back again in the same experiment. What we are doing, we are manipulating the value of potential difference in the circuit. We want to see its effect on current. So what is found when potential difference is increased, current is found to be increased. Here independent variable is potential difference and dependent variable is current. But have you noticed this? The resistance of the resistor remains constant throughout the experiment because what length of resistor is used in first case, the same length is used in all the cases, and thickness of the resistor also same, temperature also same. It means the resistance of the resistor is constant. Its value is not manipulated, its value is not changed. That's why there is third variable also which is called control variable. It is resistance of resistor. We can conclude this way: potential difference is independent variable, current is dependent variable, and resistance is controlled variable. Okay, after this now we are able to define independent, dependent, and control variable. I want to define them. Independent variable means what? Independent variable is the variable which we manipulate or vary in the experiment or research to explore its effect on the another variable. And we can take other example also. Just for example, relation between mass and weight. If we take different pieces of stone having different size, then when size increases, certainly its mass is more. And if we take its weight, then what is found? If its mass is increased, then weight is found to be increased. It means mass is independent variable and its effect on weight is seen, and that's why weight is dependent variable. Okay, mass independent variable, weight dependent variable. In the research or experiment, a variable whose value depends on the another variable is called dependent variable. Now we can take example. Just for example, we know that displacement is equal to velocity into time. Now let's find out which one is dependent variable. If we take value, just for example, if velocity is taken 10 meter per second, then after 2 seconds it will cover 20 meter distance according to this formula. And if we increase velocity 10 meter per second to 20 meter per second of the body, then within same time period it will cover 40 meter distance. And if we increase again the velocity, then the distance covered will be 60 meter. What it mean? Exactly what we are doing, we are manipulating or we are changing the value of what? Velocity. That's why it is independent variable. And on which variable its effect is seen? This is displacement. That's why displacement is dependent variable. And time is taken constant, so it is controlled variable. Okay, let's go through control variable also. What is it? In the research or experiment, the variable whose value is taken constant is called control variable. We can take example also. Let's say we want to establish the relation between velocity and kinetic energy. Velocity and kinetic energy, how they are related. Then we can do one experiment also. Look at this. This is a thin sheet of iron and it is kept on the ground. A metal ball is taken. You can take the stone also. If the stone is dropped over it from certain height, let's say 10 meter height, then what happens? The sound can be heard. Now just observe the intensity of sound and do the same experiment with the same stone or metal ball with the height 20 meter. If it is dropped from 20 meter, then sound will be certainly more. Now take the same stone and do another experiment. If it is dropped from 30 meter height, then what is found? Now sound is more than the previous two cases. What it mean? How can we relate this velocity and kinetic energy? When a body is dropped from greater height, then its velocity will be more when it reaches to the ground. And in first case velocity is less, second case velocity is more, and in third case velocity is more than other two cases. And when velocity is increased, then what is found? The sound is found to be increased. If the body has more kinetic energy, certainly the same kinetic energy converts to sound energy. That's why if sound is more, then at that time the kinetic energy contained in that body will also be more. And that's why when velocity is increased, kinetic energy of the body is also found to be increased. That's why we can conclude that the independent variable is velocity, because we are increasing it. When it is dropped from more and more height, certainly velocity increases and we are manipulating the value of velocity. And because of this manipulation, what is found? Kinetic energy is found to be increased. It means kinetic energy is dependent variable. And at this time, mass of the body is control variable. If we take more mass, in first case, let's say instead of 1 kilogram, if we take 5 kilograms, certainly the sound produced by this 5 kilogram mass will be more in comparison with this third case also. That's why mass is taken constant. This way we can understand about the dependent variable, independent variable and control variable. They are very, very important. They are used in different experiment. Just find it how many places two variables are related. In those cases, which one is dependent and which one is independent and which one is control variable. The target of this class is to understand what is variable and what are its type and how can we differentiate between them. Okay, this much for today.